All right, so this is removing duplicates from a sorted array. Dupes, sorted array, and it's exactly what it sounds like. Give it an array, 2, 3, 5, 5, 7. You would need to return an array that had the dupes missing. So it's pretty easy to tell since it's sorted. That's all. It'd be pretty trivial to just go through and keep it, and just one way would just be to add everything into a set. And then return the set as a list or something like, or return the set dot size, because we're actually trying to return the number of unique elements rather than the actual list of unique elements. But so that would be O(n) runtime, the set approach, but it would also be an O(n) space. Another approach would be to go through one by one and add it into a new result array. You know, just 2, 3, 5, and then basically you would keep, as you were adding these values in, you'd keep a previous pointer, and if you tried to add something in, like another 5, and those were equal, you would actually skip over. You would say, okay, 7, and then you would update prev 11, compare, be like no, and then you would come up with this, and you could just return this size. And it's just the same runtime and the same space. But I brought up this example because we only need a reference to whatever the current streak we're on, whatever the previous value is. Because we're really just taking these streaks and just shrinking them. So how would we do this in, we still have to visit every item. So how would we store this in less space? How would we do this in place, essentially? That would be the optimization we're looking for. Let's write it out again. If we're going to do it in place, why not just go through left to right and keep a pointer. We'll have I here, which is what we're currently looking at, and then we'll have something called a right index. Let's call that W. All the right index is a it basically tells us what we're going to put the next unique value into. So at the very beginning, it will be this first item. So let's just run through what I'm trying to say here. So ignore this first iteration where the right index is this. Say the right index was now 3. So say we somehow kicked it off starting at the first index. So we're comparing these two values, and what are they? They're right -1 and I versus, I. And we see that they're different. That's good. So in that case, we'll move on to the next iteration. And because these are both good, we can actually move the right index over because we actually don't want to write into this anymore. Now we're both looking at the 5. Same case, because we're only looking at I and I-1, or really right index and I. So, you know, we're still good. We continue. Now we get to the case where these two are the same. And in that case, right index shouldn't change. We actually want to make this spot the next spot that gets overwritten. But I will increase. We're just looking at these two now, and things have changed. So we're going to actually have to copy this value into this, where the right index is. And when things change, what do? We increase the right index. I increases, and now we're comparing these two. They're different. Great. Copy this into here. And I'm sure you're getting the hang of it. We continue, we write over 13 eventually, and the right index eventually points to here. At the end, we can realize that if we only need to return the size, we can just return whatever the right index is, and we should be set. One thing to be careful of is to notice that we're actually comparing I and the right index minus 1. You might be tempted to at first compare I minus 1 and I, but as you'll see as you keep going down this list, I will be, if there's lots of duplicates, I will be much further to the right, and the right index will be much further to the left. So the right index minus 1 always points to the last unique item, which we are trying to compare to the next potentially unique item. As code, what would that look like? So we have our right index. And like I said, since we're comparing these two, let's actually prime this for loop by saying we're going to start at 1. So 1 and say 4 equals 1, and then go to the end of the list. And then remember at the end I say we're just going to return the right index. And honestly, we're already halfway done. That's how concise the answer to this question is. What were we doing? We were comparing the values at right minus 1 and I. So if a.get at right index minus 1 does not equal a.get at I, what are we going to do? We're going to, well, what did we do when the values were unique? We would copy this value into the right index. So a.set at right index, whatever the current value is. And then we would increase the right index. And in the case where they were the same, all we really did was increase I. Remember, we kept the right index on the current value because that's the value still needed to be overwritten. So we don't actually do anything in the else case.